Hello, good afternoon. Today our guest is Professor Walker Hanlon. Hello, Walker. How are you doing?
Hey, great. How are you?
I'm great. Walker, I believe that there are some commonalities between us. We both like to study innovation. Why are you interested in innovation?
Well, I think primarily because we know technological progress is fundamental for long-run economic growth. And so, among the really interesting questions in economics, in my opinion, is how we generate that technological progress and how we sustain it, particularly over long periods of time.
All right. I'm interested in innovation because I care about the rise and fall of nations and sustaining economic progress. And Walker, you have done quite a bit of research in the arena of innovation. One of your more fascinating papers is on the role of engineers in the British Industrial Revolution. Walker,
Yeah, that's great.
why were engineers important during that era? And secondly, please explain the professionalization of engineering during that era.
Yeah, so what got me into this project is that I was looking at how people describe themselves in patent data, right, which is one important and widely used measure of innovation. And if you look at that in Britain in the late 18th and the early 19th century, so the period in which the Industrial Revolution is really getting underway, you see this increase in this group of people suddenly calling themselves engineers. So before the Industrial Revolution, there's just almost no one in the patent record describes themselves that way. And then you see this increase in people describing themselves as engineers. And so I became interested in, what did it mean for people to begin describing themselves this way, rather than, say, a manufacturer or something like that, or a gentleman or an aristocrat or something. And as I dug into it, I think, what became really interesting to me is that it appeared that the way innovation was done was changing, and that this change was characterized by an increasing professionalization of innovation. And, one of the really sort of more salient aspects of that was the emergence of this profession of engineering, which, we sort of all have an idea in our head about what engineering is and what engineers do. But if we think, there's lots of different kinds of engineering. If we think about what connects them, it's this focus on, designing, inventing things and using, scientific principles as and mathematics and other tools like that as part of that process of developing new technologies. And that really appears to be what was happening at this time. There was this rise of this new group of people who, rather than being, say, a textile manufacturer who occasionally invented a textile machine, was a group of people who really were professional designers and inventors. They did a wide variety of things, but they sort of, this was the core of the new occupation that was emerging.
Exactly. And Walker, were engineers more likely to patent?
Yeah, so within the patent record, we can see that these engineers are different than other types of inventors, and that suggests that there's something about them that's special, right? So individually, they're patenting at higher rates than other types of inventors. They're also patenting in different ways. They're working across a wider range of different technology types, and they're more likely to work with co-inventors as part of teams, and they're producing higher quality patents, right? And so they're just sort of, as a group, they just look different than the types of people who were inventing most of the stuff before, which was mainly manufacturer inventors, people who had a manufacturing business in a particular line of work, like textiles, and invented technologies related to that specific line of work, right? These engineers just look different. They look more like general purpose, sort of designer, inventor type of people.
All right then, Walker. And what I find interesting about your paper is that you argue that engineers, well, not just engineers, but inventors were more likely to work with people outside of their respective professions. Tell us a little about this scenario.
Yeah, so these engineers that you see, they're working in bigger. They're more likely to work with other inventors or other types of inventors. And you can see that in the patent record. And those sort of partnerships take a wide variety of different forms. But a famous one is like Watt and Bolton, where Watt is this sort of seminal, really fundamentally important inventor of steam engine technology. And he partners up with Matthew Bolton, who is more of a businessman, has political connections, right? And so they're working in teams. Sometimes these teams, I think, are bringing together different types of knowledge. Other times, I think the engineer is providing like the inventive spark, but they're working with people who can help them commercialize these inventions, or help, with political connections, help them protect those inventions. And I think that allows these engineers to focus their efforts on the invention side of things, and through focusing their efforts, just sort of in a standard like Adam Smith kind of story, like the pin factory, when you specialize, you divide up the tasks. This group is focusing on the task of developing new technologies, and I think they're becoming better at it than other types of inventors.
Were engineers formally educated?
So not at the beginning of the profession. So I mean, today, if we were talking about someone as an engineer, we would typically be referring to someone who has an engineering degree, right? But that's not what happened at the early stages of the profession, because engineering schools came after the profession was already established. So what was defining about these people was not that they held a particular educational qualification. It was that they did a particular type of work in a particular way. And early on, a lot of the engineers, they were self-taught. They were more likely than other inventors to have a working class background, or to have done an apprenticeship. And they certainly embodied skills that we associate with engineering, like scientific understanding, technical and mathematical skills. Most of those, though, are not coming through some sort of formal education. They're coming through self-study. And so this is a group that's not really defined by an educational qualification. They're defined by what makes their occupation special. It's core occupational function, which is designing new types of things. And then the actual education system that we know of for engineering, that actually followed the development of the profession rather than leading it.
Walker, in your article, you note engineers were almost completely absent from the patent record prior to 1760, but they appeared in growing numbers after that point. What was responsible for the change?
So, I mean, there's two things to say about that. So one is that it's, people might find it weird that there's no engineers before 1760, because certainly engineering work was being done, but it was typically being done by people who were not specialists at that work. And so the nature of the change is that you have a profession that really specializes in these type of design activities. What generated the change? But it's a hard thing to pin down. In my paper, I have a model that describes one of the mechanisms that could have generated it, which is, again, essentially bringing Adam Smith's idea about, the size of the market and allowing specialization in particular types of tasks into a growth framework. And the idea there is basically, there were some early innovations, there was some population growth that were basically allowing the market for new inventions to expand, right? And that expansion in the market for new designs and new inventions, allowed a group to begin specializing in that activity, because specialization, in this theory is only possible if the market is large enough to sustain, people who specialize in those activities. And so at least in, my theory, which provides, I think, one potential mechanism that may have driven this emergence, right? It's basically the expansion of the market allows people to begin specializing in this task, design and invention. And once you have that, once people begin specializing, that allows the economy to achieve a higher growth rate than it did before. It puts the economy on a new, higher, sort of modern growth path.
Did engineers engage in specialization across a wider range of industries?
Yeah, so the engineers that you see, so on the patent side, you can see them working across a wider range of different technology types, and I think that makes perfect sense. If you're if you're someone who's a manufacturer inventor who has a textile factory, you're likely to invent textile technologies, but not to connect those ideas with things in in other industries that you're not active in. Whereas if you're a specialist in invention and design, like these engineers, right? I think one of the features of that specialization is that it allows them to connect ideas across a broader range of different technology types. And so you see them working on a broader set of technology types than other types of inventors.
Walker, there is a
Mhm.
difference between a quality patent and a low quality patent. On average, were the patents of engineers of a higher quality?
Yeah, so these engineers, I mean, we have various ways of measuring patent quality, and none of them are perfect. It's a little bit different than today. So today we might measure patent quality through something like citations. That didn't exist in the historical setting that I look at, but there's a range of different ways that we can measure patent quality. One is whether they paid patent renewal fees, for example, to keep patents in force. Across all of the range of patent quality measures, these engineers seem to be producing higher quality patents than other types of inventors. And, that's just one of the, I think, really important dimensions along which they look fundamentally different than other types of inventors.
Walker, what is the crucial distinction between an engineer and another inventor? What is so special about the design process incorporated in engineering?
Right? It's hard to know exactly how these different inventors are going about their tasks, right? But we sort of have some sort of general idea, going back again to Adam Smith, right? That if you specialize in a task, you may be able to become more productive at that task. And so, I think what's going on here is that if you have a manufacturer inventor who's trying to run a factory and manage a business, and then they're also doing some invention on the side, right? They may be pretty good at those tasks, but they could probably be better at the invention part of that if that's what they focused on, right? If they had more time for that and they were, exposed to more ideas, talking to other inventors, rather than spending a lot of their time managing their factory or selling their product or, financing their operations. Right. And so I think, though it's very difficult to establish empirically, I think it's reasonable to think that by specializing in this design and invention type activity, right, and not doing other things like managing a large factory or maybe working with a partner who does that management side while you do the invention side, right, that can allow you to become more effective at your sort of your core occupational task.
Were these engineers wealthy or ordinary people?
So, many of them came from the working class. So they typically have a less wealthy background than the average inventor. And, they often, gain their skills either through self-study or through apprenticeships. After they become an engineer, there's a wide variety of outcomes. So certainly some of them, like Watt, become, very famous, very wealthy, very successful. Others, I'm sure, don't do as well. Many of them are sort of obscure. We see engineers that, you'll see in the patent record, but we don't know much about them. Presumably they weren't that successful. So I think there's a wide variety of outcomes because, innovation is a fundamentally risky activity, and sometimes you're going to be successful, and sometimes you're just not going to invent something that turns out to be, economically valuable. But certainly some of them did well, and in terms of background, I think that suggests that it's offering potentially, and I think this is something that I'd love to see more work on, or maybe do some more work on myself. Potentially, it offers a path sort of upwards for people who are smart and hardworking and willing to do a lot of self-study, but come from a very modest background.
Was the engineer the bridge to commercializing research? In your paper, you say that the engineer was a mediator between the philosopher and the scientist.
I mean, that's exactly how engineers saw themselves. So that quote actually comes from one of the early meetings of one of the engineer groups. And, that's how the engineers, certainly, in the early 19th century, were seeing themselves as like someone who, took lessons from science and math, and then used them to solve practical problems. During the Industrial Revolution, there's a lot of debate about when and exactly how science influenced the development of useful technologies. But to the extent that that was happening, I think it's very likely that engineers were this key bridge, because they're a group that really, we know that they had access to a good amount of scientific knowledge, and yet they were working on practical problems. And so, I think that they were a crucial bridge between these two groups, and certainly that's how they saw themselves.
Exactly. And you also contend that the reputation of the engineer became inflated, whereas in the past, people saw the engineer as an inept workman or someone who was not overly talented. And let me read this aspect of your article. This poor reputation had been overturned by the early 19th century, as symbolized by the erection of a colossal statue of James Watt in Westminster Abbey in 1834. What had changed? MacLeod 2007 argues that the strongest case for revising the inventor's reputation as an untrustworthy projector stemmed from the country's growing awareness of major technological achievements.
Yeah, I think that's right. I mean, these engineers, they differed from other groups. So for example, like a millwright or a wheelwright, which was a more established, profession that went back in time and had an established apprenticeship system, right? And early on in their history, these millwrights who were doing something kind of similar, and actually, I think, to some extent, were like a predecessor of the engineering profession, right? They looked down a little bit on some of the engineers, because the engineers didn't have this type of apprenticeship, formalized apprenticeship training, most of them in like these type of like millwright activities. Some of them had done an apprenticeship in those activities, but many of them hadn't. Some of them hadn't done an apprenticeship at all. And so they were looked down upon a little bit, because they sort of were outside of, the well-known, well-respected occupations. But certainly by, the 1820s or 1830s or 1840s, I think the success of the technologies that had been generated, particularly by engineers, was just completely undeniable, and that really raised their reputation. And these ranging from Watt's steam engine to the railroads, to all sorts of other types of technologies. I think the country and the world was just becoming very aware of the success of these technologies and how important they were economically, and the fact that behind these technologies, in many cases, was an engineer.
The improving mentality, as posited by Anton House, led to the Industrial Revolution. So I agree with the statement to an extent. People are becoming more affluent, and as such, they gained a greater level of appreciation for the technical expertise of the engineer.
Yeah, I think that's right. I mean, the sort of, their reputation increased because what they were doing was successful.
And what's also compelling is the transferability of skills. So you refer to someone, Brahma. Brahma was trained as a carpenter and worked installing water closets before he turned his attention to developing new inventions. Therefore, engineering was a profession for the excited, the autodidact, the one who was confident in his own abilities, even when they were not validated.
Yeah, I mean, he's a fantastic example of this process of, someone who has done an apprenticeship in carpentry, but clearly has a broader mindset and a real interest in invention and, solving practical problems. And so, yeah, he's working at, as a water closet installer, or manufacturer, and starts inventing some technologies related to that. But then you can see, in the patent record, you can see him change the way he describes himself to, over time, he starts describing himself as an engineer. And along with that change in how he's thinking about himself, right, is this change in the types of technologies he's generating, where it's broadening out. And, by the middle or end of Brahma's career, he's producing all sorts of things, from presses to beer engines. And so you can just see that, in a way, it encapsulates the whole engineer story in that one career. And the other thing he's doing is, helping to train the next generation of engineers. And I think it's that, that first generation passing it on to the second generation that starts to make this a more stable profession.
Walker, was there a difference between manufacturers and engineers, or did engineers transition to manufacturing over time?
Well, I think the right way to think about this is, how do you make money off of your inventions? And there are various ways that you can monetize an invention, right? You can invent something and use it in a manufacturing process in a factory that you own, like Arkwright did with his textile machinery, right? You can form a partnership like Watt did, or you can and particularly later on, you can sell your invention and monetize your invention that way, right? And these are different, these have different implications for the development of new technologies, right? Because if you're going to invent something and then you're going to monetize that by running your own factory using your new technology, right? Then you're going to have to spend a lot of your time doing things other than invention. You're going to have to spend a lot of your time, managing and doing the finances and all the other things that running a business involves. Whereas, towards the middle of the 19th century, you start to see a lot of these engineers inventing things and either forming partnerships or licensing out their patented technologies, or just straight selling their patented technologies. That's something that, like, Bessemer, for example, did quite a bit of. And that allows them to continue to invent, which in some cases is a great thing for some of these people, because some of them are very good at invention and just not very good at running businesses. And so that they can, continue to focus on invention, what they're good at, while basically transferring their intellectual property in a way that allows them to monetize things, but allows other people to actually do the running of the business. And I think that change was key, right? Because that allows specialization. And if you can't transfer the intellectual property that way, either through one of these channels, right? Then in order to take advantage of an invention, you're also going to have to be a manager. And that may not be something that an inventor is great at doing, but it's certainly going to take time away from what they may have a comparative advantage in, which for many of these people was inventing or designing new technologies.
Were these individuals motivated by money?
Money was certainly part of it, right? I mean, they almost always needed to make some money. I don't think that, they were entirely motivated by money. There was certainly a lot of just genuine curiosity, a lot of desire to, sort of invent the next great new technology that everybody would be impressed by. So it certainly, money wasn't the only thing, but money was an important thing. I mean, they needed to make money, and especially because many of them came from modest backgrounds, they needed to be able to support their own inventive activities through monetizing the technologies that they were generating. And you kind of see that early on with many of these engineers. So Watt, for example, when he's working on his steam engine technologies, he's also working as a civil engineer during part of that period, because he's got to support himself. And so, that's an example of a case where money is important. They need to be able to make money. If they want to be able to specialize in this activity, they need to be able to make enough money from it to support themselves.
And I would contend that many of these individuals were motivated by the desire to attain status and the respect of their peers.
Yeah, I think that's absolutely true. I mean, that's, of course, a harder thing to sort of quantify in the way that an economic historian might want to quantify these sorts of things. But I think, the historical record suggests that certainly was an important motivation for people.
Were these innovators willing to share their inventions?
To varying degrees, yes. I mean, there was certainly lots of interest in professional societies where they would go and talk about the technologies that they're generating. We know from individuals, surviving records that there was a huge amount of, correspondence through the mail where they would discuss ideas and, and share insights. And so I think there was a lot of that. Certainly when it came to, sharing, technologies that they had paid to patent, I think, they wanted to, in many cases, the reason they were patenting, and certainly not every technology that engineers invented was patented, but the stuff they were patenting, they were trying to, at least limit the sharing to the extent that they could be, compensated for those kind of activities.
Would you attribute the productivity of engineers to co-inventing teams?
It's hard to know how important co-inventing was. I sense that it was important. When I look around and, for example, the job that I do, certainly, working together with other people is something that generally makes us more productive. And I think that's true in lots of jobs that involve creativity and coming up with new ideas. So it seems very plausible to me that was important, sort of separating that importance from other things like the gains from specialization. Right? That's a very hard thing to do in a rigorous way, but I think it's very likely that played an important role.
Let me read this excerpt from your article. One reason that engineers may have been more productive is that because invention and design was central to their profession, they may have been better able to form co-inventor teams. Co-inventor teams may have been beneficial either because they brought together individuals with complementary technical skills or because they helped inventors partner with those who were more able to fund or commercialize inventions. Across the period, co-inventing was generally rising, a pattern that has also been documented in more recent periods.
Yeah, I mean, so I think that's, obviously I agree with that statement. I think, co-inventing was important. It was clearly a feature of, as the technologies were becoming more complex over the 19th century, co-inventing was increasing for all types of inventors. It's just that the engineers seemed to be sort of ahead of the curve relative to other types of inventors, in that they were working together with, they were more likely to work together with others, and not necessarily with other engineers, but also with a variety of other types of people, including manufacturer inventors, who I think, could have played an important role in helping them commercialize things.
Basically, it seems plausible that co-inventing led to more innovations because of the cross-fertilization of ideas.
Yeah, I think that's absolutely right. And it's in thinking about innovation, right? We often think that, it may be becoming harder to invent new things because the new things, the sort of the easy ideas have been invented. The next technology is going to be more complicated and more complex. And this rise of teamwork, I think it could have been one of the sort of forces offsetting that, allowing the rate of technological progress to be sustained.
What type of inventions did engineers produce? Yes, just shed some light on the differences in technology type and scope.
I mean, they invented across a very wide variety of different technologies. They were certainly more dominant in more mechanical technologies, particularly early on, which were really the key technologies of the early Industrial Revolution. Those, whether it's sort of steam engines or textile technologies or machine tools, like they were very important in those types of areas. Later on, you see them broadening into other areas as the sort of technological progress broadens. So you start to see at the very end of my study period, people calling themselves like chemical engineers, which is something you wouldn't have seen early on, right? And today we know that the engineers, if we look for engineers, we can see that lots of different kinds of engineers. And so we can start to see that process occurring in that first half of the 19th century. But they, even individually, people were very diverse in the types of technologies that they were working on. And they weren't always just doing invention either, right? A lot of these engineers, were doing other things. They were doing design work, like producing new sort of innovative types of infrastructure projects, solving, civil engineering problems. And, that's another group where in my article, I also talk about the changes going on the civil engineering side and the strong connections between people doing more civil engineering type design work and people doing more, mechanical engineering type inventive work.
Yes, and you refer to Bill Addis, and Bill Addis cited John Smeaton.
Yeah, so Bill Addis has a really fantastic book about, basically construction engineering and the development of construction engineering. And in his book, he's got a chapter that talks about the period that I'm talking about but the construction engineering side, and, this sort of second half of the 18th century, and he calls this the professionalization of engineering. So, the same process that's happening in the inventive side of engineering, so people producing mechanical type technologies, the same sort of professionalization process is happening on the civil engineering side, right? And there it looks kind of similar. So civil engineering had been done, like what we would call civil engineering work, long before civil engineering became a profession. But what's changing in the Industrial Revolution period is that civil engineering is starting to be done by people who really specialize in it. They do lots and lots of big projects. They are trained by other civil engineers, so they come up through a training regimen, typically inside these civil engineering firms. And you have these really important people at the early stages of that process, like Smeaton, and Brindley, and then later people like Telford, who are basically, developing this professionalization on the civil engineering side.
How did the engineering profession maintain quality?
I think it was pretty competitive, and there was a lot of competition among engineers to be the best. I think on the invention side, it's probably a little bit different than on the civil engineering side. On the civil engineering side, I think these engineers were competing to try to get contracts, and that was based in part on the success of their previous projects and how well they stayed within budget, whether they had issues that had to be fixed later. On the invention side, I think a lot of it was that whether they produced an economically viable, useful technology was the key to getting some sort of monetary reward, and also non-monetary esteem. And so I think it was essentially competition was generating this this pressure to maintain quality and to push quality forward.
Exactly. And in your article, you list the Society of Civil Engineers, the Institution of Civil Engineers, and the Institution of Mechanical Engineers. They were founded 1771, 1818, and 1846, respectively. So what we're observing by this stage is that engineers were not only becoming more productive, but they were also investing in schools to disseminate further information related to innovation and engineering.
Yeah, I think that these societies played a really important role in providing a forum for engineers to come together and share ideas, building the early institutional structure of the field, and starting the process of generating a formalized set of, a formalized engineering education system, right? And what's interesting, and I think what's, particularly, I don't know if I'd say unique in Britain, but, notable in Britain is just the extent to which the government played very little role here in these types of activities. And it was really these societies, these sort of, societies of engineers themselves that were developing this new profession and generating a lot of the institutional underpinnings for the engineering profession that we have today.
Engineers created a pipeline. So before there was the absence of a pipeline, but with the professionalization of engineering, people were encouraged to become engineers and the status of the profession inflated.
Yeah, and I think, the example of very successful, important early engineers, I think played a key role in drawing new people in. So, Watt's success, people like Smeaton and Brindley and the, really sort of visible, impressive types of infrastructure projects they were generating, and the attention that people like this were receiving, I think that this made it an attractive profession and started drawing people in. And by the middle of the 19th century, I think there was becoming a more established route to be an engineer, which typically involved working for one of these established engineering firms. And that's when the profession is really becoming sort of solidified.
And after this period, manufacturers, they started to incorporate engineering science to process new products. This is when we begin to talk about the relationship between academia and industry. So had it not been for the professionalization of the engineering profession, maybe manufacturers and other entrepreneurs today wouldn't fully appreciate the link between academia and industry.
Yeah, I mean, that's a hard counterfactual to really,
It can be tested.
Yeah, it's hard to know what the world would have looked like without this. But I think, it is possible to sort of see the types of activities that engineers were doing and the way that they were bringing scientific, concepts, scientific understanding in to solve these practical problems, in ways that were, motivated by the demands of the market for either new technologies or new infrastructure.
Do you know what's another captivating counterfactual? This one, had it not been for engineers, or should I say, had it not been for the professionalization of engineering, would the quality of infrastructure decline? So I would love to see a study looking at the quality of infrastructure prior to the professionalization of engineering.
Yeah, I mean, that would be a really interesting study because, I think it's amazing to look at how, how, especially on the civil engineering side, things were done before this emergence of a real professional group of engineering firms. So if you look at how in the first half of the 18th century or the 17th century, how big infrastructure projects were done, a lot of those big infrastructure projects were being run by a head engineer who had very little experience in doing major infrastructure projects. And so, they were kind of, many of them were really brilliant people, but they were kind of learning as they were going. They weren't, bringing to these major tasks this high level of experience. And today, the idea that we could have a major infrastructure project being overseen by an engineer who had no experience as even an assistant in a major infrastructure project is just kind of, something we would never see. And so you would expect that would have had implications for the quality of these projects.
I'm thinking about the personalities of engineers at that time. Would you say that they had a peculiar personality type?
Well, that's a hard question to answer, I think. I'm not sure I have a really clear enough sense to say that one way or the other that they differed in personality type. I think they very well may have had different characteristics, but it's I think that's a hard thing to study.
Well, based on reading manuscripts or listening to characterizations of these people by biographers, more than likely they were high in openness to ideas, but also introverted.
could have been. I mean, they were certainly, I think, willing to challenge existing ideas about how things should be done, and to introduce their sort of new concepts of, new ideas, new technologies. So there must have been some openness to new technologies. Whether they were introverted or extroverted, I don't know. It would be a really interesting thing to study.
The Industrial Revolution is interesting. On one hand, it first occurred in England. The British people were said to unleash our intellectual ingenuity. But on the other hand, in places like France, there were massive investments in technical education at the same time. There in other European countries, the literacy rate was even higher. So again, we wonder, why did the Industrial Revolution occur in England?
Yeah, and I think you can kind of see this in miniature just within the engineering profession, where in France, there was a lot of public support for the engineering profession, but it was very tied to the types of activities that the state was interested in, primarily military activities, but, also to some extent, other types of major public infrastructure projects. And it looks very different than the engineering profession that emerged in Britain, which was essentially, had very weak links to the state and was really driven by the kinds of economic rewards that developing, say, new technologies in, textiles or a wide range of different other things, it's basically driven by the market rather than by the state, and it generated very different outcomes in terms of the profession, what the profession of engineering looked like, and what types of problems the engineers were working on.
And in Britain, people were more receptive to certain types of innovation, and they had a better appreciation of the role of innovation in fostering change. And this is just my opinion. Whereas in France, the innovator was presented as someone from the upper class, who was highly educated. Britain had a different culture. It was the workshop of the world, so British people respected the average man who worked.
Yeah, that could be true. I mean, again, there was certainly resistance to new technologies within Britain as well. I mean, the Luddites kind of most famously. Whether Britain's sort of openness to these ideas that, by the middle of the 19th century was a cause or sort of, a pre-existing condition, or whether that was a product of the success that these technologies brought, I don't know. Would be a very interesting thing to study.
And another interesting thing to study, and I'm sure you have written on it and read the studies, is the link between the Industrial Revolution and science. How much science was required for the Industrial Revolution?
It varied a lot by sector. I think, more was required in things like steam engine technologies than in textile technologies, which were important for the Industrial Revolution, but, could typically be developed by, sort of skilled craftsmen who had some mechanical understanding and an interest in tinkering. So I think it varied a lot by sector. In the early decades of the Industrial Revolution, certainly by the middle of the 19th century, I think it's becoming more and more important. And by the end of the 19th century, it's, when we see, big advances in things like chemicals and electricity, right? Once you're at that point, then it's really fundamental. Scientific understanding is really central to developing new technologies.
Walker, for nearly 1 hour, we have been discussing the Industrial Revolution, engineers, and we did not mention apprenticeship. The apprenticeship program was crucial to the success of the British.
Yeah, I think that's right. And if you look at the engineers, I mean, so a lot of them have an apprentice background. It's interesting, though, that apprentice background varies a lot. It's not that they all have a millwright apprenticeship or something like that. A lot of them were carpenter apprentices. They did a wide variety of different types of apprenticeships, typically always sort of a craft type of apprenticeship early on. And so I think that the types of skills developed through this apprenticeship programs were important for engineers, but I think that they also played a second role, which is that, engineers were designing and developing new ideas and new technologies, but those also required a lot of craft skills to be carried out. And I think the apprenticeship, and my colleague Joel Mokier has done a lot of work on this. And so,
Excellent work.
yeah, of course. And so have many others, right? That the apprenticeship program that existed in Britain, I think, provided a very ready supply of these type of skilled implementers that could take these designs and make them successful commercially, whether it's technological designs or infrastructure type designs.
Exactly my point. The apprenticeship program in Britain, according to some researchers, was superb in a sense because it transcended kin boundaries. The Chinese also like planned a similar system of apprenticeship, but their apprenticeship system locked innovation within the clan, whereas in Europe, the free flow of ideas was allowed.
Yeah, I
It
think,
was not clan based.
yeah, so there was room for entry, and I think that was important.
Exactly. Now, we often hear that necessity is the mother of invention. Some time ago, you produced a paper on the topic. Is this thesis true or is it just a fable?
Well, what that paper was about was this idea of directed technical change, which is really that the factors available in the production process and how those factors are changing is going to be influencing the types of new technologies being developed, right? And so what that paper showed is, during the US Civil War, when it was very hard for British cotton textile manufacturers to get access to US cotton, that they developed a whole bunch of new technologies to allow them to switch over and use other types of cotton more effectively. And so, they sort of saw this necessity, which was that there was a shortage of a particular input to the production process. And you can see the technologies that are being developed shift accordingly to try to basically help them deal with this, with this shortage of one of their inputs.
Walker, would you say that there is a difference between innovation in the 21st century and innovation during the era of the Industrial Revolution? I would say yes. In the 21st century, innovation occurs along the line of the platform. So Facebook, Twitter, WhatsApp, Snapchat, Instagram, these are platform and they facilitate communication across borders. Whereas in the past, innovation I would say required a greater level of technical analysis and competence. Computer science has advanced and clearly the code to create apps and other social media platform is difficult, but innovations in the 21st century are more of a social nature than a transformative nature.
I mean, I think, on that point on the social nature, I think it's clear that, we're both producing different types of innovations, but the way that innovations are being produced has also been evolving, I think, since the Industrial Revolution, because just sort of by necessity, innovations have become more complex. We need more knowledge to invent the next new good idea. And so you've seen the rise of, first engineers, which are sort of professional inventors, then sort of entire organizations based around designing and inventing new things. And, that type of, whether it's a professional research lab or a government research organization, right? These are basically bringing together more and more people in these teams to try to generate new good ideas. And I think that's a reflection of the fact that the technology is becoming ever more complex and requiring ever more knowledge to make the next step.
Yes, I agree. Technology is becoming more complicated, but the nature of the innovations being determined by technology are not as complicated as they should be. Let me give a perfect example. Innovations in energy versus innovations in IT, in particular social media, both complicated, but one has a more transformative impact. Facebook is important for business people. Facebook has reduced the cost of advertising. Instead of paying a brand expert, you can go on Facebook and promote yourself. But I can live without Facebook, and so can you. And this is the argument of people like Robert Gordon. Innovation is declining on the level of on the level of transformation. The innovations that are being generated by the present economy are important, but we can live without some of them.
Yeah, I mean, I think, the same argument could be true in the past. I think, my view is that actually the modern innovations, a modern innovation system, the problems that we face now with the digital world, like, I tend to think that they're not that different than the problems in the past. And that's because, while technology advances, technology is still all wrapped around humans, and that sort of, I think, frames these things in similar ways. So I think that there is, if anything, I tend to think that people think that things today are maybe more different than they really are. And one of the things I'm struck by as an economic historian is sort of reading about people discuss things in the past, is how strong in some cases the parallels are to today.
I agree with you, and I respect the opinions of Robert Gordon, but I also believe that the market responds to innovation, or rather, innovation respond to the market. There is a demand for platforms. Jonathan Nee has a book on the subject matter, the rise of the platform. People want to listen to Addison Ray on TikTok. Even serious professionals are on TikTok because TikTok can be leveraged as a platform to build their brand. So innovations must respond to the market.
Yeah, I think that's true. Innovations respond to the market. And, but I think, going back, like, the development of widespread newspapers also had these big impacts and allowed, changed the way people communicated, and the way people communicate is changing again. It's always changing. Whether these are sort of different in some fundamental way, I'm not quite sure.
Do you know what's fascinating? The decline of old media. Is old media declining because of technological disruptions like the internet or Facebook, or was old media declining before the advent of Facebook and other disruptive technologies?
Yeah, that's a good question. I don't know the answer because I haven't studied it, this particular question, but my sense is we're just developing new additional substitute consumption goods here. We had newspapers in the 19th century, pamphlets and books, and we've added to that television, and we've added to that the internet and all of the social media platforms. And I think we're just adding more and more sort of substitutes that are vying for the same amount of time, and so they're pushing each other out. But again, I'm not an expert on that topic.
And I'm yet to see a proper paper on the topic. Based on what I've been reading anecdotally, it suggests that old media was declining before the mass use of the internet.
I mean, I would assume that that's got to be true because, I don't know, it depends on what you say, what you think of as old media, but certainly the widespread availability of television impacted newspapers, right? Because it provided a substitute way to get your news and other types of information. And I think, television itself has been impacted by the internet and the social media platforms because they provide another substitute. Whether that's a fundamental difference, I don't know.
And remember, newspapers were created for a particular target market. So after a while, when more companies begin to produce newspapers, it becomes obvious that only a small group of people really enjoy reading the newspaper.
Well, in the 19th century, a lot of people enjoyed
it was the fad at that time.
Yeah, it was the dominant, at least in the middle of the 19th century, the dominant form of getting your news.
But it's always interesting to study developments in media, and the biggest development today is the metaverse. That's everywhere. So Korea apparently is the first country to be incorporating the metaverse in politics. I just saw the article. But that's a term that's being used quite frequently.
Yeah, I think it's frequently used and infrequently clearly
Defined,
defined.
exactly. But I think that if we don't define the metaverse, maybe it can prevent politicians from regulating it. We don't want politicians to regulate the metaverse before we can benefit from the gains of innovation.
Yeah, I have no idea where it's going. That's sort of far beyond the things that I think about.
Well, I'm thinking about it a lot because it's everywhere. It's online, it's on YouTube, it's on Bloomberg, and I like stocks. And this is one of the reasons why I'm following the metaverse, because I think that the potentials are unlimited. But we have been talking about the Industrial Revolution. You wrote a second paper on immigration titled Skilled Immigrants and American Industrialization, Lessons from Newport News Shipyard. Shed some light on this paper.
So that paper was written in combination with another paper about a broader paper about the American shipbuilding industry. This paper in particular, what it's talking about is the development of this Newport News shipbuilding company, which is, a really important part of U.S. history, and now remains this fundamentally important shipyard in the U.S., which kind of emerged out of nowhere in the late 19th century. And what the paper is about is the extent to which being able to attract foreign skilled craftsmen, in this case, skilled metal shipbuilders, primarily from Britain, played an important role in allowing this firm to be successful in the early years. And it uses some census data to show how important this group was in these really specialized tasks that you had to know in order to successfully produce large metal ships. And the fact that the U.S. companies like Newport News really needed to go abroad to find these people, because the industry was dominated by the British.
All right then. So Walker, you said that, okay. Walker, you said that this paper was written in conjunction with another paper. I'm wondering, is this the paper Evolving Comparative Advantage in International Shipbuilding during the transition from wood to steel?
Yeah. And so, I mean, the broader question is this interesting pattern where if you look in the middle of the 19th century, the US is this very important, international shipbuilder, because most ships are built out of wood and the US has lots of wood. And so they're really a dominant world shipbuilder. Canada is also quite important. But if you go to 1900, when most ships are built out of metal, right, by that point, the US and Canada have essentially lost their lead, and it's been taken over by particularly Britain, which, the paper basically talks about how that's due to the fact that the British have cheaper metal. And so that allows them to get this early lead in the industry. But what locks the lead in is the fact that by doing this activity, you develop the skilled workers and this pool of these really specialized skills, like bending, very large metal sheets into these irregular patterns that you need for ships. And so Britain developed this labor pool, and it really helped them lock in for a long time their advantage in this industry, even when they had lost their advantage in cheap input costs.
And the Americans, could they have invested in other technologies to avert the collapse of the shipping industry? Because in your paper, you write that America couldn't compete.
Yeah, I mean, basically the early lead that the British got in producing metal ships, it allowed them to develop this labor pool. And once they had developed that locked in labor pool, of skilled workers, it became very hard for countries like the US to compete with them outside of, and this is one thing my paper shows, that the US, was successful in the Great Lakes, where they were essentially protected from competition because it was hard to move big ships up into the lakes. But on the coast, the US was never really able to successfully compete in producing, large merchant shipping with Britain, even though there was lots of government subsidies across the early 20th century, because they just had this major disadvantage in terms of the supply of skilled workers.
Obviously, there are many cases where subsidies just do not work, yet people keep recommending them.
Yeah, I think this is a case where it just wasn't going to be, the subsidies that were offered just weren't overcoming the pattern of comparative advantage, and so, um, yeah, the U.S. industry remained very, very dependent on government orders.
All right. Walker, we have been speaking for 1 hour. I'm really enjoying the conversation, but unfortunately, I have to wrap up. So bye.
Yes, great talking to you, Lipton.